Hi everyone, this video is recorded to show simple activities of Virtual Experiment 1. In this experiment, we interface virtually between a designed PIC-based device on Proteus simulator to a C#-based program on PC. In this experiment, PC send a specific commands when a user press any button on a C# based program and send this command to this Proteus device. In this experiment, this is the C# wind form, تمام? That we implement it on Visual Studio 2019. Here is the code of C#. Here is the command R, command Y, command L. That is the PIC-based device that we designed in Proteus, or the student can design in Proteus. It simply consists of two LEDs, one red LED and one yellow LED, and an LCD. This is the micro C code for this big device that we designed. Simply, this Proteus device work as a real one, work if we have a real device, and we can implement it as a real device. So when we run this schematic like that, we found that this basic words appear on LCD, and this is our C# based program. When we press red button here, notice what change will be happen on this red LED. When I press this button, the red LED is on. When I said yellow button, red LED is off and yellow LED is on. When this button LCD is pressed, this sentence will appear on our LCD, which make a test that the command of LCD is performed or is executed on our big device on Proteus, and so on. When I again press red LED, the red LED will on. When I again press yellow LED, the red LED on. And when I press LCD again, the same sentence will appear on our LCD. So this is a simple example of how interfacing between the computer or PC and between an external device virtually. This is our experiment 1, which we learn and teach a student, which we teach a student how to make this interfacing using our RS232 technology or protocol. This is the COMPIM serial RS232 serial communication. تمام. Okay. To make this virtual experiment work, we need this program, as we stated in our paper. This program, virtual serial port driver, which make a virtual connection between what is called COM1 and what's called COM2, and another pairing between COM3 and COM4. When we connect between computers or C# program and our device on Proteus, we make this device on Proteus work in COM1 or on COM2, like that. So this device will working in COM2. When we implement our virtual code, our C# code, we make the application or make the window form of our C# code will work in COM1. This program will work in COM1. So COM1 on our C# window will form, and COM2 in our Proteus device. COM1 and COM2 is paired using virtual serial port driver to uh, to simulate, and to make virtual connection between COM1 and COM2. As a result, we make virtual connection between our Proteus device and our C# program. I hope this video illustrates the concept of sending commands from PC to big base device on Proteus as a virtual experiment one. Thank you. Hi everyone. This video is recorded to show simple activities of virtual experiment 2. In this experiment, also, we interface virtually between a designed big base device on Proteus simulator to a C# based program on PC. In this experiment, the big base device will send information from LM35 sensor, temperature sensor, from the big base device on Proteus to the window form or C# window form on LPC. Again, in this experiment, the direction of sending it data is the reverse of the direction of sending commands in virtual experiment 1. In virtual experiment 1, the commands will be sent from window the C# window form to a big based device. In this experiment, the information will be sent in reverse direction from a big based device to the C# window form. In this experiment, as we stated previously, the reading of LM temperature sensor will be sent from this big device to the window form, C# window form, and will be appeared here in our text box here. We will execute this experiment now. When we run the device, first of all, this big base device is connected to PC again via or through COM-BIM, which represent RS232 protocol, and this is the RS232 connector. When we get properties of this component, we will find that now in this experiment we make this COM-BIM will work in COM1 as illustrated in this window. In our in this C# window form, in our C# code, we don't put that this window form will work in a specific COM, but we make the user or the student can select freely from this window form to work with any other COM port, Let us run the program or run the experiment and find what will happen. Now the reading of our sensor is 50 Celsius or 50 degree. As we stated that COM-BIM connector on this experiment will work in COM1. And we stated previously in experiment 1 that COM1 and COM2 are pairing together. So when we run this device, we will now here in our C# window form will freely select that can work in COM2. All COM ports in our PC or in our Windows will appear here. This is because we write this function serial port.get port names, which will get all COM ports in our Windows system and display them on this combo box, on this combo box component. So the device will work in COM1, and now our C# window form will work in COM2. We select to work here in COM2. After that, we will press read data button, which will manage reading data from big device and display them in our text box here. When we will press read data, the temperature degree will appear here like this. If we alter the degree, maybe increasing our temperature degree like that to become 58, this degree is appear here now, 58 like that. If we increase it again to 70, تمام, this degree is read here on our text box or in our C# window form. This experiment is intended to teach the student how interfacing between big device on Proteus to send specific data or sensor data, تمام, to this C# window form. Again, this virtual connection between Proteus device and C# window form cannot be happen without using virtual serial port driver. I hope this experiment is illustrated correctly, and I hope this experiment to make a big illustration or an obvious illustration of how interfacing big devices and big devices which connected to sensors and send information of these sensors to C# window form. Thank you. Hi everyone. This video is recorded to show activities of Virtual Experiment 3. In this experiment, we emulate virtual interfacing between a USB-based device on Proteus simulator to a special program called HID terminal, which is one of built-in programs inside microC editor. This is our Proteus USB device, and this is the microC code for our USB device on Proteus. If we want to call HID terminal program, we can go to tools on microC editor and click on it, and then we can call HID terminal from here. Like that. This is the HID terminal program that built inside microC editor. HID terminal program can be used to do two tasks. The first task is that descriptors, code lines of any USB and big microcontroller based device can be built easily and quickly using such a program. We can build quickly descriptors of any USB device by using micro C editor from from its HID terminal program from here. In micro C, we should write all these code lines because these code lines represent the descriptor of any of our USB device in Proteus. So instead of writing all these code lines, we can generate them using microC editor from HID terminal program from here. The second task is that it can be used as an alternative. The second task is that the HID terminal can be used as an alternative of a C# based program to just make a simple test if any USB device can communicate with such HID terminal program or not. To use HID terminal program for testing, we should activate the terminal panel from like that. In this experiment, HID terminal is used to send some characters to a Proteus-based USB device, and then a USB device will reply by sending the next characters to HID terminal again. Each character will be replied with its next one according to the micro C code inside our designed USB device. We should work on now. This our USB device, and this the alternative of a C# based program, which is called HID terminal. When we run the USB device on our on Proteus, please focus here. Please focus here. This is the sound of connecting a new USB device, and this the name of our USB device appears here on HID terminal. We will send now some characters to our USB device, such as A, B, C, D, E, F, G, H. Sorry, we will write here some characters like A, B, C, D, E, F, G, H, and so on. And we will click on send button to send these characters to our USB device, and the reply will appear here. And the reply of this USB device will appear here. We're sending these characters to the USB device, and these are the replied characters from our USB device. We notice that when we send character A, he reply here with character B. When we send character B, he reply with character C. We write the program inside the big microcontroller to reply with next character, reply with each next character for each sending character from HID terminal. This is an obvious example that we can make a USB device and interface it with our PC via HID terminal program virtually without executing any hardware or any real devices. I hope this experiment is obvious, and thank you. When we want to close or disconnect our USB device, we should stop Proteus simulator and close completely the Proteus program. Please focus here, and here the name of our USB device is disappeared, and we listen and we hear that a USB device is disconnected from our computer, such as real USB devices work. Thank you. Hi everyone. This video is recorded to show activities of Virtual Experiment 5. In this experiment, we perform virtual interface between SD memory card and BIC18F452 microcontroller to record reading of humidity and temperature from virtual DHT11 sensor and store them inside the virtual SD image. First of all, we should run WinImage program. WinImage program is used to explore the contents of such SD card image or create a new SD card image. Now, we will explore our SD card image that will be used in our experiment. We run it from any location like that. We can open our image from here. Our image is under this folder and under the Proteus folder here. And this is our image, SD card image in our experiment. As you see, there is only one folder. This folder have nothing. So we make sure from that this folder is empty, is empty, except this folder only. To work with this card image, we should close this image and close WinImage program. So to close this image, we will go to File here and press Close Image, like that, and then close WinImage program. This is our schematic circuit. As we say previously, it consists of DHT11 sensor, which provide humidity and temperature readings. This is the virtual SD card memory, which we used in Proteus. And these are two LEDs, red LED and green LED, which are used to indicate the status of the SD card, if it is detected successfully or not. Now we will run Proteus, and before running Proteus, we should make sure that our image card is loaded here. So click, right click and press its properties like that. We should make sure that this card image is our card image. So we will explore or browse the computer. Yes, here, this is our folder. تمام. And when go to Proteus folder, we found our image here. It's okay. We will run now, and I want you to notice or focus on transition between red LED and green LED. Green LED is on now, and green LED is on now after transition from red LED. This indicates that big microcontroller detect and found the SD card image successfully, and now it will work with it. When we notice here, we will find that there is a reading related to CPU load. Now, CPU load is 51, 45, 40%. We will work, we will run this experiment for a little while to find if the reading of 77 humidity and 77 humidity and 34 as temperature reading will be recorded in a file inside this card image or not. Now the reading 69, 79, it means this reading of this high CPU load, meaning that writing now, writing process on SD card is happened now. 83, 73 means that now there is a writing process happened or will be happened on this SD card. Now it reached to 43 and 70, 69, 70, and so on. When this percentage comes low, 29, 50, it means no reading happened on our SD card. So we will let it for a while of time, a while interval of time, and come back again. Hi everybody, we return again after our experiment in Proteus is working for a little of time. Now we will stop running. We will stop running now. And we will go to explore our SD card image. You will open one image now. Open. We will select our SD card image.mmc. We will find here there is a new file in our SD card image called a.txt, and it is correctly according to our micro C project or micro C code. All reading, all temperature and humidity reading are stored in a files. All reading for an hour will stored in a file, and all reading for a day will stored on a folder, and so on. But we can't waiting for a day to show that a folder is created and 24 files inside it are created as a reading for humidity and temperature. We will open this file, extract all file into the same folder, yes, and we will find that the file contains temperature and humidity reading. The reading will be taken approximately over consecutive time intervals, 5 minutes. So I think this for reading means our program work for 20 minutes. I hope this experiment is obvious. And this is an obvious example about how interfacing SD card with a big microcontroller, and consequently with a PC to store reading of sensors such as the HT11 for storing temperature and humidity. Thank you. Hi everyone. This video is recorded to show activities of Virtual Experiment 6. In this experiment, we perform virtual interface between a C# Window 4 on PC with a real-term program via serial communication. A real-term program is used as a virtual alternative of actual GSM GPRS modem we use in our experiment, in real experiment, GSM modem called SIM 800L. Any GSM GPRS modem provide its services by sending the corresponding AT command, what is called AT command of any task or service. These services include making voice calls, sending SMS or MMS messages, sending data packets over internet. To make such tiny GSM GPRS modem to work as IoT devices. Each GSM GPRS modem type has its own datasheet that include its private AD command formats. Our SIM 800L modem, this is the datasheet of this SIM 800L modem, which include all 80 commands that can be used within actual SIM 800L modem. The student can download it easily from its official website. This experiment will show sending SMS 80 commands from the C# window form that the student can design it easily, and it will be displayed on real-term programs. All these commands that will send from this C# window form can be displayed on real-term program, and we will make sure if syntax of the SMS 80 commands are correct or not. When using actual hardware components instead of real-term program, real SMS messages will be sent actually from a PC to cell phones, to cell phone or cell phones of the prospective receivers. In this experiment, we will need to use again virtual serial port driver, which explained previously in experiment 1 and 2, to make virtual pairing between two COM ports. For example, we use in this experiment COM3 and COM4 and make pairing between these COM3 and COM4 by using virtual serial port driver. Here, this is virtual serial port driver, and COM3 and COM4 have virtual connection between them. In this experiment also, we will make C# window form will work on COM3, and we will make real-term program work in COM4 like that. As we see in our C# code, we make this code and we make this window form will work in COM3 with baud rate 9600. This is window form. It will work. It take such time to work. This is our window form that we design, and the student can design like that or more complex than that. We just write phone number of the receiver here, and the content of SMS message will be written here, and this button is used to send the SMS when work with actual hardware. This is the counter. There is an information that maximum number of characters that can be sent, especially English characters that can be sent via only one SM message is 160 character. So we make a counter for users to count down when the users add any characters here. This counter will count down. as we see when work with our experiment. So in the source code, we make this window form to work with COM3. In real term, we will press port panel here, and we will choose to work with port 4 and make this port work in baud rate like what you write in the source code of C#. In source code of C#, we will make this window form to work with 9600 bit per second, and real term should work with the same baud rate, 9600 bit per second. To make this port work really in within real term here, we should press this open button twice, like that and like that. Here, as like that, real term work actually with COM4. Now we will send our SM message, which all commands of this message will be displayed here. Instead of sending these commands actually to GSM modem or to real GSM modem, if we connect it through USB 2 to L converter with our PC. Now we will choose any number like that. This is my phone number, and I will write any content. Hi, like that. When I add each character, the count is 135. When I add any characters, any more characters like that, the counter will count down here. I will press now send SMS messages, which will send the commands to real term program like that. Here, all the commands that can be used, all command sequence that can be used to send actually SMS message, تمام, in case of connecting real GSM modem, is displayed here in real term program. We should begin with a command called AT plus CMGF equal 1, or any SMS message sent should begin with this command, and then the second command and new line. In the next line, the second command will be send AT plus CMGS, and including this command, including the phone number that I write here. And then next line or new line, and the content of all messages send after that. And the content of our SMS should be ended with Control Z character, with Control Z characters. This is the format of sending SMS messages. All command sequence appears here correctly, and we repeat again. If this command is displayed here correctly, it will actually execute it and will be sent to the receiver with this number when we using or connect real GSM modem and connect it with this PC. I hope this experiment is obvious, and this experiment is just an obvious example about how interfacing, how make this PC can use and can make all services of GSM modem when sending SMS messages, when making voice calls, and when using it in sending data packets as internet to make these tiny devices work as IoT device. Thank you.